Hi folks, this is my first video, and this video is what happens when you're an engineer, you've just retired, and you haven't found that perfect part-time engineering job yet. If you found this video and you live in the United States, you probably live in one of the red areas and have already determined that you want to reduce the radon levels in your house. This is normally done by either boring one or more holes through your basement slab into the gravel to evacuate the air, or with a sealed sump lid. I'm going to cover the sealed sump lid method with test results at the end. Apparently it's going to be a cat video also. If you would like details on the sump lid installation, you may want to check out Walt's Reviews, RM Spelt's Farm, and Tex Fox. I found were a couple that I looked at. I do want to mention that, we have another cat in the cat video, that the flange on the sealed sump, shown here, the flange is larger than the sump that you have. So it goes around the outside, you anchor it and caulk it to the floor. Then the lid here can be removed. It's held on by a seal. And this particular cover, which is Everbuilt from Home Depot, I believe I've seen the same cover advertised as a Jackal, also has a clear inspection cover, which also can be removed. Okay, so what are we looking at here? Here is the sealed sump lid, and here is where the sump water would come out, and here is where I've installed the radon gas removal system. And this, I'd already installed it when I thought about making a video here, but what I want to show you is in this sump, the question is, would this work, and how could I tell ahead of time, as opposed to going to all the trouble to put a sealed system over the sump and then find out it doesn't really work. So in your sump, we'll go down in here, you'll find like this sort of dirty looking plate pipe here. There's a pipe coming into the sump. Now, this is the only pipe coming into my sump. And the question was, did this guy really connect to the slab drains that go all underneath the concrete in your either slab or your basement slab? And how could I show that? So I'll show you in a second how I did that. But one of the key things here is that pipe has to be exposed to the air, meaning if that pipe was completely underwater, which was how mine was originally, you can put a sealed sump system on and you'll never pull any air through it. And also there's a way using a test system to figure out if this is going to work. In my case, the water level was normally above the level of that pipe, and I had what was called a pedestal type sump pump installed. The submersible type pump that you're looking at now actually makes the water level lower. So it's not that the pump is like better or anything like that, they're just different. And with the submersible pump, the water level in the sump is naturally lower, and that exposes the pipe. Here's the radon meter that I bought. It's Airthings is the brand. Corinthium Home is the manufacturer. I got this, I believe, off Amazon, and they're about $120. With this meter, one of the things I did was then put it over my old unsealed sump lid. So it would be setting it, let's say, here over the gap, and took readings with that pipe exposed to the air and with that pipe covered with water. And I'll show you the results here. Here's the readings with the radon meter with the pipe underwater, so around 20. So 20 sounds really high, but our levels in the basement at a normal height were around 5. So we were above the EPA level of 4, but we weren't extremely high. As you get very, very close to the floor, your readings are going to get significantly higher. So here we're right on the floor. We're reading about 20. But notice with the pipe exposed, we're 140, 7 times as much. Did take several readings because radon readings are notoriously variable, but you can see as an extreme amount of difference and no overlap at all to data. So definitely that pipe, when it's exposed, properly connects into those slab drains, and it's a good location to pull air from underneath the entire slab. Because I still had the old pedestal pump around, just wanted to show you the difference between the two. So that's the pump in the box on the right, that's the pedestal pump, and then the box for the submersible pump on the left. And you can see how much lower that submersible pump sits. And then also with a sealed sump lid, you wouldn't have a spot for the pump shaft housing and the float rod to work with that sealed sump. So I'm zooming in here. So here you can see where the water lines were with the sump, with this pedestal pump, and the submersible pump, it's way down here. And even though this float can be adjusted some, it still wouldn't work. So here's the air evacuation with the radon gases in it. 3-inch hole here, and the inlet to the radon fan was 3-inch. So I used 3-inch pipe, PCV pipe, all the way up to where I exit out through, in my case, out through the wall here. Now I could have gone through here because we're in a walkout that's above ground, but then I would have had to core through the whole of the poured basement wall. Up here I was able to go through the wood, and then I cored, we have a brick fascia out there, so I did get a borer and core through the brick fascia. Here's the installation from the outside. This Fantech motor is a different shape than the traditional round motors. I was going to look for a thin motor and mentioned that to someone at work, and they said that they and their brother had used a rectangular shaped motor. So thanks Ken and Don for their recommendation. Going around to the back of the motor, you can see where the motor sits on the pipe coming through the wall, where I had core drilled through the brick fascia, so it attaches there. Then there is a bracket that attaches to the adapter, and then I've added, after a short piece of pipe up to my brick ledge, where I go with 245s around the ledge, a masonry attached angle bracket to the double thickness where the 45-degree meets the straight pipe, and screwed it into there to help support the weight of the pipe above the fan. Going on up the outside wall, because it's siding, I had to put 2 brackets farther up that actually go into the attic, where I could put some wood reinforcement to attach the brackets, and then 2 more 45 degrees around to the eave, where I have a saddle bracket made from Trex decking, and then out the top. I painted the PVC pipe using directions from a Bob Vila video, where you sand the pipe, wash it down with acetone, and then use Krylon spray paint. I found Krylon spray paint by us is carried by Menards. So here we are up on the roof. Here's my pipe. Fan's running. This is fairly heavy surveyor's tape. It gives you an idea of how much air this fan is moving through the system here. So there's a pretty good airflow rate coming out. The saddle bracket that I made from the piece of Trex, and you can see it spaces the pipe then, so that the pipe does not contact the shingles and smash here. There's a little gap. And I hook it in with some of the internal hex type star fittings, which is a lot better to work with when you're up on the ladder, because you don't need to push so hard. And these are exterior grade as well. So how does this system perform? Here's the levels in the basement. We were at about 5 before the system was installed. After it was installed, clear down to about 1/2. And that's what I'm measuring outside. And that's about what the EPA says our outside levels are and where we live. Upstairs, we were always a little below. We were 3, but again, we're right down to like 1/2. So many fold reduction in radon. The system works very well. So the cat, because everybody says people watch cat videos a lot, more people might watch this video. So thumbs up. If you haven't fallen asleep by now, let me know if you're interested in a follow-up video where I look at the electrical savings and performance of the system running the fan on a part-time basis.